Hey, what's up guys? My name is Grady. I'm with Simply Embedded, and today I'm going to show you how to create an 8-bit counter in Verilog HCL. So, without further ado, let's get started. Alright, before starting to write the code, it's always good to have a block design of the system you want to design in Verilog HCL. So in this case, I've put a block design together for you guys. So in the system, we have an 8-bit counter, a binary to BCD converter, 7-segment controller, a counter clock generator, and refresh clock generator. So we've already learned about how to create clock dividers, and we've done the binary to BCD converter, and we have done the 7-segment controller as well. So now, the only thing that's left is to create the 8-bit counter and tie the whole system together. Throughout this tutorial, I'll leave the block design on the screen so you can refer to it anytime as you want. So without further ado, let's get into the tutorial. Alright guys, let's get straight into the project. So for this project, we're going to reuse our previous Verilog codes that we've written, or Verilog modules that we've done. So in order to do that, you just add sources and find those previous Verilog modules that we've done. So for example, we're going to use 7-segment display controller modules and binary to BCD modules. Other than that, we won't go into details on how we set up the 7-segment controller and the binary to BCD converter. So since we took the 7-segment controller module, it was named as top. So we will start off by copying the whole top module from the 7-segment controller to the actual 7-segment controller module. So you can copy paste that in, and we're going to modify that. So we're not going to have the buttons and switches anymore. Now we're going to have ones, tens, and hundreds instead. That's going to come from the binary to BCD converter. Also, we won't have a clock divider there anymore, so you can remove that. Make sure you have the right connections for the refresh clock, and so there's no more buttons anymore. So digit 4 is going to be connected to 0. You can also rename the top module to 7-segment controller. So instead of having 2 top modules, we don't want to confuse everyone. So now you can go back to the actual top Verilog file, and we're going to delete all the information that was for the 7-segment controller earlier there. We're going to rename it and input it and set it up as the 8-bit binary counter. So all this information can be gone. So we're going to have a clock divider for the refresh clock of the 7-segment controller. So that's going to be a 10 kHz clock signal. In order to make our code more efficient, we can use the same clock divider module over and over again by modifying it just a little bit. So go ahead and open up the clock divider module, and now we're going to add a hashtag, a parameter. So that's going to be a global parameter that can be modified outside of this Verilog file. So we can modify it by this syntax. Set up the hashtag 4999 in front of the refresh clock generator, and we can do the same thing with the next line and set up a 10 Hz clock divider by writing a larger value. So we can set up the binary to BCD converter. And again, if you are not sure how to set up the binary BCD to converter, check out this card right here, and you can go ahead and find out how it works and what you can do in order to make it work. You can set up the binary to BCD converter by going back and looking through in what order the inputs and outputs are set up. Same thing for 7-segment controller. You can go ahead and set it up and make sure all the connections are correct. And again, if you don't know how to do the 7-segment controller, check out this video right here so you can learn how to do that and set it up. So now we're going to create this 8-bit counter that is going to be a key to our system to create a counter on the 7-segment display. So the counter output will be 8-bit counter, and we're going to have an input switch. So based on the switch position, we're going to make our counter either start counting or stop counting. So whatever you would want to do, you can make it reset the counter if the switch goes to 0. You can make it to stop or whatever it is. So essentially what we're saying is that the counter is equal to counter if switch is 0, which means that we hold the same position. Other than that, we keep counting. So what will happen if the counter reaches the max value? Now that we've written the counter code, we can go ahead and set it up in our top module and connect it to the whole system. So we're going to have an input switch, We're going to have the counter clock signal coming in at 10 Hertz. So after you've set up the counter, the clock dividers, and so on, you can go ahead and create a test bench, set it up, and run the test bench so we can test out our code without running the synthesis and implementation. This way you can save some time as usually. So make sure you always simulate before implementation. It's highly important, and I just want to emphasize it so much. You're going to save a lot of time if you test out your code in the simulation before running the synthesis and implementation. So go ahead and run the simulation, drag in some values, some key values. So I want to see ones, tens, and hundreds. Drag in refresh clock and counter clock signal to show the clock difference. So the refresh clock should be 10k Hertz and the counter clock signal should be 10 Hertz. This will take you some time, and I'll just fast forward at this point. You can see the counter clock signal changing. The value counted up, so that means that we're all good at there. So set up your XTC file, make sure you have anodes, cathodes, you have that one input switch and one input of clock signal. So as soon as you flip the switch, the counter stops counting, and when you flip the switch down to a 0 position, the counter will stop and keep its previous value until you flip the switch again and it starts counting, and so on. You can add more functionalities like reset functionality maybe, or you can have a countdown to functionality. You can make a stopwatch out of it. You can make an alarm clock out of this. So this is really the base for everything. So from here on, you can go and take this material and set it up as a whatever system you want as a 7-segment display. So thank you so much guys for checking out this video. I truly appreciate it. If you like this video, hit the like button. And if you are new to this YouTube channel, consider subscribing. Other than that, keep up the good work, and I'll see you next time.